In this video, we will investigate the habitable zones around the Sun and other stars. We start with a view of the Sun, and the white lines show the range of the habitable zone around the Sun. The blue orbit for the Earth is in the habitable zone, and notice that Mars in the red orbit is outside the habitable zone. You can also see Venus, the white dot, moving in an orbit that is too close and is not in the habitable zone. Next, we will move to an exoplanet system, Fomalhaut. This is a star that's one of the nearest to the Sun, and it has an imaged exoplanet. So what you're seeing now, the white lines again are showing the range of the habitable zone around this star, which is much hotter than the Sun. So the habitable zone is farther than what you see for the blue and red orbits of Earth and Mars. Next, we will move to a star that is cooler than the Sun, the TRAPPIST-1 exoplanet system. So we're seeing now, again, the white line showing the range of the habitable zone around TRAPPIST-1. And this is extremely close to the star in comparison to, again, we see the blue and red orbits for the comparison of the distance for the Earth and Mars orbits. We'll zoom back into the view of the region around the habitable zone, and this system has 7 known exoplanets and contains systems that are too close and hot to be in the habitable zone, 3 exoplanets in the habitable zone, and additional planets that are too wide and cool to be in the habitable zone. So we'll next view simulated images, not actual images, but this is a simulated image of one of the exoplanets that would be too close and too hot to be in the habitable zone. All the planets in this very interesting system are terrestrial, not giant planets. So next we'll view a simulated image of one of the exoplanets in this TRAPPIST-1 system that is actually in the habitable zone. Remember that that's the region where liquid water can persist, and so what you're seeing is a simulated image of an exoplanet with a substantial amount of liquid water. And then finally, we'll move to a simulated view of an exoplanet in the TRAPPIST-1 system that would be outside the habitable zone. And in this case, because the temperatures are much cooler, instead of seeing a liquid surface, you see an icy surface. And so this gives you an indication of the different types of exoplanets that might be present in this TRAPPIST-1 very planet-rich system with 7 exoplanets together. Now, the habitable zone is very important for understanding the Drake equation, and so the habitable zone factors into one of the terms of the Drake equation, which is quantifying the current number of communicative civilizations in the galaxy. So that's what the Drake equation is solving for, and then we'll step through each of the terms. N star is the number of stars in the galaxy. Fp is the fraction of stars with planets. That relates to the exoplanet chapter that you studied earlier in the class. NHZ gives the number of planets per star that orbit in the habitable zone for longer than 4 billion years, with that lifetime being important when we consider the age of the Earth and the presence of life on Earth. So the next term, FL, gives the fraction of planets with life. Then the next term, Fi, gives the fraction of planets with intelligent life. And finally, Fs quantifies the fraction of the stellar lifetime with a technological civilization.